Hey guys, so I wanted to talk to you about continued ratios, but before we do that, I just want to kind of review ratios really quick. So if you remember from before, a ratio is a comparison between two numbers. So, we look at it often as a fraction. So it might be 2 cups of sugar for every 3 lemons in a recipe for lemonade. So we could increase the amount of lemonade that we're making from one recipe, which requires 2 cups of sugar and 3 lemons, to something more than that. Let's say we wanted to make 5 recipes of it. Well, then we would just multiply the top by 5 and we would get 10 cups of sugar. And we would multiply the bottom by 5 and we would get 15 lemons. But the thing is that in this ratio, it reduces to 2/3 still. So in a ratio, it is just saying that the fraction or the comparison reduces down to this, but that there is some number that you would multiply top and bottom by to get this. So the ratio of 2/3 says that for every 2 cups of sugar, we need 3 lemons. So I could take and multiply 2 by any number, which I'll call x, and multiply the bottom, 3, the number of lemons, by that same number, x, and it would still give me that ratio of 2/3. I'm just multiplying top and bottom by the same number. Now, when you think about when we learned fractions and fraction families, that's exactly the same thing that we did. We said in a fractions family, it was 2/3 and 4/6 and 6/9 and 8/12, and every time we were taking and multiplying numerator and denominator by the same number to get some other member of the fraction family. Again, like this one would be 2 times 4 over 3 times 4. This one would be 2 times 3 over 3 times 3. This one is 2 times 2 over 3 times 2. So this original fraction or ratio is still in there. It's just we're multiplying by the same number, numerator and denominator, over and over again. Now, often, because it's easy in math to use it, we write it as a fraction, but I believe we also talked about the fact that sometimes we write ratios like this. It's not as easy to make computations with that, but that is another way that we would write it with the colon in between. So this would be our 2 cups of sugar to our 3 lemons. But this means the same number, that there is some x value that we could multiply both 2 and 3 by, and it would reduce to this ratio. So with that in mind, I want us to talk about continued ratios. Right? Continued ratios are ratios that we write in this format, but they continue on. It's not just a single ratio or a single pair of numbers. We could say this was the 2 cups of sugar and 3 lemons, but then maybe we would say it's 2 cups of sugar to 3 lemons to 4 cups of water to, 1 mint leaf or something like that. And so it's a continued ratio. It goes beyond just the typical comparison of 2 numbers that we think about and adds more ingredients or whatever, more elements to this ratio. But what it's saying is that every single number gets multiplied by that same x value. So like we did over here, we said that there's some number x, which we multiplied the 2 by and the 3 by to get back to that ratio right there of 2/3. It's the same thing here. This would say 2x and 3x and 4x and 1x, right? So for example, if we were making this as lemonade again, and we wanted to use 8 cups of water because we wanted to make, let's say, enough to serve 8 people, that value that we would use for x would be 2. So we could get 4 times 2 would be the 8 cups of water that we want to use. That means we have to do it, we would have to double everything. So it would be 4 lemons and 4 cups of sugars and 6 lemons and 8 cups of water and 2 mint leaves, right? So we would just double everything. Or if we were having a huge party and we wanted to make 20 servings of this, then we would do 2 times 20, which would be 40 cups of sugar. That is so much sugar. And then we would do 3 times 20, which would be we would need 60 lemons, and 4 times 20, which would mean we would need 80 cups of water, and then 20 mint leaves. All right, but the point is that each time we just multiply that number that's in the ratio by that same value of x. All right, so again, the continued ratio is a ratio, but again, loosely think it continues on beyond the typical first two that we see. Okay, so we are going to do a couple word problems that involve continued ratios, and I'm just remembering that I left my paper in the printer, so hold on for a second. So you should have this sheet right here, right? It's the beginning algebra, ratios and proportions, and you are supposed to solve the following problems and define your variables and show all work. Some of these problems are not going to be super easy to define the variable, but we will do that when it's possible. All right, so 4 people chipped in to buy a lottery ticket in the ratio of 4 to 2 to 3 to 6. The ticket won $84,000. Calculate the first person share of the winning. All right, so this is the first person right here. So the first person gets 4 times some number x. The second person gets 2 times some number x. The third person gets 3 times some number x. And the fourth person gets 6 times some number x. So you might think, well, gosh, I don't know what that means. But again, x is the value that actually we would use to get these 4 things to total up to the $84,000. So what this is saying is that 4 times some number x plus 2 times that same number x plus 3 times that same number x plus 6 times that same number x has to total up to $84,000. Again, what it means is that without that all of these reduce, again, it's 4 times some number, 2 times some number, 3 times some number, 6 times some number, but they all reduce to this, all right, because they're multiplied by the same number. All right, so 4 times some number plus 2 times some number plus 3 times some number plus 6 times that same number is going to give us $84,000. All right, so then this is just a really super easy algebra problem now to do. Again, think about our steps. Do we have any distributive property we can do? No. Can we combine like terms on each side? Yes, big time right here. 4x plus 2x is 6x, 6x plus 3x is 9x, 9x plus 6x is 15x. Nothing we can combine on this side. All right, then we would take and see if we can get all the x terms together on one side. It's already done. Get all the constant terms together on the other side. It's already done. And then divide by the coefficient of the x, which would be 15. That would be our last step. And so we would get x equals, well, let's see, 15 goes into 84, 15 goes into 96 times, so this will go in 5 times, 84,000 divided by 15, 5 times 15 is 75, this would be 90, 15 into 90 is 6, and then the rest are just zeros. So x is 5,600. All right, so then we go back up here and it says find the first person share. This is the first person right here. So if x stood for $5,600, the first person gets 4 times that much. All right, so 5,600 times 4, 0, 0, 4, carry the 2, that is 22. All right, so the first person gets $22,000 out of the $84,000. Now we could go through and do that for each person. The second person gets $5,600 times 2, 0, 0, 2, that's 11. The second person gets 11,200. The third person, let me do it up here, gets 5,600 times 3, 0, 0, 8, carry the 1, 16, so they get 16,800. And then the fourth person gets 6 times 5,600. Again, they didn't ask us to do this part, but I just want you to see that when we take the sum of all these numbers, we end up with 84,000. So we get 0, 0, 6 times 6 is 36, carry the 3, and then that is 33. All right, so the last person gets 33,600. When we add those all together, 33,600, I so did not leave enough room for this, 16,800, 11,200, and 22,400. We get zeros in each of these columns. 6 and 4 is 10, 8 and 2 is 10, so that gives us 20. 3 and 6 is 9, plus 1 is 10, plus 2 twos gives us 14. 2, 3, 4, 5, 6, 7, 8. 84,000. Okay? So again, it comes from knowing that if they form that ratio, that there is some number that builds it up to the actual amount that it was. It reduced to this. And so we say, what was that actual number? And we put it in each of those spots, and then that has to add up to the total. So there's our equation. This is our answer to what is x, and this is the amount that the first person got. Okay, I'm going to do one more, and then I'm going to pause or stop to do a second video. All right, so sum of 24,000 is to be divided into 3 shares in the ratio of 3 to 5 to 7. Find the largest share. Again, whatever that share is, we're going to find the x value and then multiply it by the 7. And I'm saying that's the largest because it's the biggest of the 3 numbers. Okay, so again, we're going to have, because it's in this ratio, it means that there's some number x that we're multiplying by each of these 3 and then adding them up to get to the 24,000. So it says 3 times x plus 5 times x plus 7 times x has to equal $24,000, right? Again, it could be any x that we want, but the one that we're looking for is the one that makes it equal the $24,000 that was the total. All right, so we could break it up into shares and do 3 times 1 and 5 times 1 and 7 times 1, but then the total would only equal $15. We want it to equal 24,000. Okay, so again, no distributive property. Next step is combine like terms. So this is 8 and 7, which is 15x equals 24,000. Just coincidental that it's 15x again. And then we're going to divide by the coefficient of the variable. So 15 into 24,000. 15 goes into 24 once. 14 minus 5 is 9. Bring down the 0. That's a 6. We get 0 and then the remaining zeros. So x equals $1,600. And then the largest share is the person that gets 7 times that much. All right, so 1,600 times the 7. 0, 0, 2, carry the 4. That's 11. So the person that gets the largest share is getting $11,200. Okay, I'll be back in a little bit with some more practice for you.